Question 44 CY 2021. There are four options regarding actinides are given, so you have to choose the correct statement among these four options. It can be one option or it can be multiple option. Now we can look into the options first. Option A, the 5f electrons of actinides are bound less tightly than 4f electron. Option B, the trans uranium elements are prepared artificially. Option C, all the actinides are radioactive. And last, option D, actinides do not exhibit actinide contraction. So you have to choose the correct answer among these four options. Now coming to the answer, we will go through each option. First, option A, the 5f electrons of actinides are bound less tightly than the 4f electrons. This statement is actually correct. And why I am saying it depends on 2 points. First one, 5f orbital is further away from the nucleus rather than 4f orbital due to opening of new principal quantum number. And the second point is 5f orbital is more diffused in space than 4f orbital. This is also because of opening of new principal quantum number. Since the principal quantum number increases, the size of the orbital increases. Thus, with the increase of size, it becomes more diffused in space. And with the help of these 2 points, that is, it is further away and it's further diffused from the 4f orbital. The electrons of 5f orbital will feel less attraction from nucleus than their 4f counterparts. So this statement is correct. That is, they are less tightly bound than 4f electrons. Option B, the trans uranium elements are prepared artificially. For telling that whether this statement is correct or not, we have to go in the actinide series. First actinium, then thorium, then proactinium, then europium, then neptunium, then plutonium, then americium, then curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, and last lawrencium, 89 and 103. We can divide this actinide series in three we can divide this actinide series in three different portions owing to their presence in nature. The first portion is from actinium to uranium, then americium to lawrencium, another portion, and one small portion neptunium and plutonium. I will tell why I am differentiating among these actinides. So the first four, actinium to uranium, they are naturally abundant. So they are naturally abundant. Now, from americium to lawrencium, they are prepared by radioactive transformation, that is alpha decay, beta decay, etc. And apart from radioactive transformation, they are also prepared by nuclear fission reactions. So it is quite evident that from americium to lawrencium they are prepared artificially. Now, what will be the fate of neptunium and plutonium? They are usually found in nuclear reactors. Thus, they are formed in the nuclear fission reaction. Okay. Apart from that, very little portions of neptunium and plutonium are found along with naturally abundant actinides. They are found in very little portion. So in general we can say that neptunium and plutonium also formed artificially. That is nuclear fission reaction. Thus this statement that tells that transuranium elements are prepared artificially. The transuranium elements are actually starting from americium and ending at lawrencium. So this statement is correct. Now coming to the next one, option C. All the actinides are radioactive. Whether this statement is correct or not, we can say from this diagram, that is number of neutron versus number of proton plot. And you can see this line, this is stability range, where n by p equals to 1. You can see more or less up to 20 proton number, atomic number 20, that is about this range. Okay, so most of the elements up to atomic number 20, they lie on the stability range, so they are very much stable. If you go beyond 20 atomic number, slowly the elements will deviate from the n by p 1 plot. Now coming to the actinides from 89 to 103, so they will lie in this region. Now if you draw a line from the plot to 89 and 103 proton number, we'll find the region of actinides. Actinide region. So they are very much deviated from the stability range that is n by p equals to 1. So in case of actinides, the n by p value is very much higher than 1, and it is evident from the plot. And you can also check from the plot that various kind of radioactive decays are possible from the actinides. So the blue beta decay. So these are the blue beta decay regions. This is the orange neutrino decays. This is neutrino decays. The yellow is alpha decay. Here is the alpha decay. The green are fission reaction. So there are areas where fission reactions are there. Thus, it is evident from this plot that all actinides are radioactive. So you can say that this statement is correct. Here we will show some of the transformations, radioactive transformation. This process is called N-gamma process. Now if we put the uranium beta decay for 23 minutes, this will make 239 neptunium 93. Another beta decay for 2.3 days will form 239 plutonium 94. If you do one more neutron gamma cycle, it will be 240 plutonium 94. You put another N gamma cycle. Beta decay for 14.35 ER will give 241 americium 95. After one neutron gamma cycle, this will be 242 americium 95, and this will give, after beta decay of 16 years, okay. So it is evident that all the actinides are radioactive. Option D, actinides do not exhibit actinide contraction. You have to know what is actinide contraction. Now the configuration of actinides 5F 1 to 14, 60, 0 to 1, 7S 1 to 2. Outer orbital and 5F inner orbital with valence electron. So the valence electron goes to the 5F orbital. Now the screening effect or shielding effect of orbitals is S greater than P greater than D greater than F. From this we can say the penetration effect orbitals is again S greater than P greater than D greater than F. So the F orbital has least shielding effect and least penetration effect or penetration power. Thus the S orbital which is having the highest shielding effect and penetration power, they will come inside the inner F orbital will move inwardly that will be contracted, and this contraction is called actinide contraction. So this is very much a proper thing in case of actinides and elements after actinides. So the statement that is actinides do not exhibit actinide contraction, it is completely wrong. This is one phenomena in the atomic structure or periodic table that is called actinide contraction, came from the name actinide itself. So this statement option D is wrong. Thus we find the answer. So the first option, 5f electron of actinides are bound less tightly than 4f electron. This is right. Transuranium elements are prepared artificially. This is also right. And C, all the actinides are radioactive. This is also right. Only option D, it is wrong. So your answer is A, B, and C. For reference, you can look into the lecture on D and A block elements by Professor Devashish Ray, Department of Chemistry, IIT Kharagpur, and this is the required YouTube video. Thank you very much.